We have seen that the recurrence relation for towers of Hanoi goes like this. T of n is equal to 2 into Tn minus 1 plus 1. Given the initial condition, T1 is 1. Now, I can write Tn minus 1 as 2 times Tn minus 2 plus 1 with the initial 2 as it is and the last one as plus 1 as it is. Now, I can further simplify this as 2 square Tn minus 2 plus 2. I've just expanded the bracket and multiplied 2 throughout. Now, Tn minus 2 can be further written as 2 square 2 times Tn minus 3 plus 1, and the rest of plus 2 plus 1 remains as it is. Simplifying this, we get T of n as 2 cube Tn minus 3 plus 2 square plus 2 plus 1. If you are probably not understanding, you have to stop or pause the video, pen down things yourself, and it will be much clearer. The next is, as usual, Tn minus 3 can be written as 2 times Tn minus 4 plus 1 plus 2 square plus 2 plus 1. Now, this becomes 2 to the 4 Tn minus 4 plus 2 cube plus 2 square plus 2 plus 1, and the process continues. So, what can we write in general? In general, Tn can be written as 2 to the r Tn minus r plus 2 to the r minus 1 plus so on up plus 2 square plus 2 plus 1. Now, we know that T1 is 1. This was the initial condition. And if I have to write here as T1, I write n minus r equals 1, and hence r is n minus 1. I've just taken r to the other side. So r becomes n minus 1. Now, I can write T of n as 2 to the n minus 1. In place of r, I'm going to substitute n minus 1. So it becomes 2 to the n minus 1, and n minus r becomes 1. Therefore, it is 2 to the n minus 1 t plus 2 to the n minus 2 plus 2 to the n minus 3 plus so on plus 2 square plus 2 plus 1. And for simplicity or for calculation, I'm going to just substitute T of n as x. We're going to simplify this, and I'll substitute back as T of n. So now for simplicity, let me write this as x, and the right hand side remains as it is. And now I'm going to multiply 2 on both the sides. When I multiply 2 on both the sides, it becomes 2x equals 2 to the n plus 2 to the n minus 1 plus 2 to the n minus 2 plus so on plus 2 cube plus 2 square plus 2. Now, I'm going to subtract this equation and this equation, and what do I get? On the left hand side, 2x minus x, we get it as x, and that is equal to 2 to the n minus 1. How did I get 2 to the n minus 1? You see, these terms 2 to the n minus 1, 2 to the n minus 2, so on, 2 cube, 2 square, and 2. All of these get cancelled, and what remains is 2 to the n and 1. So it becomes x equals 2 to the n minus 1. And this was initially T of n, and hence T of n is 2 to the n minus 1. This is the solution for the problem of towers of Hanoi that we have studied in the previous video.